Very good morning to all. We are discussing about the statistical measures in design, statistical considerations in design, and we have discussed about the initial things related to probability distribution, and we are in the same part probability distribution. So, friends, after understanding the concept of what is statistics, then what is the raw data, what is population, what is sample, and what is the processing of raw data and how it is represented as histogram and frequency polygon. Let us have a discussion related to central tendency and dispersion. There are three different points. So we will discuss that how to measure or calculate the mean, then variance, and then yes, you can go for it. So these are the three different terms that we will go for. Then we will solve a numerical, and then further we will go for the probability distribution concept. So let us start. So what are the measures of central tendency and dispersion? So most popular unit to measure the central tendency is the arithmetic mean, denoted by letter mu. So arithmetic mean, we have here before also discussed many times about this, or we all know the concept of mean. So the central tendency of this particular normal distribution, or we can say, is the arithmetic mean denoted by mu. To how to calculate this particular arithmetic mean? So the population consists of n observations such as x1, x2, x3, x4, x5, dash, dash, xn. Then we can say the mean is given by summation of x divided by total number. So you will get the mean. This is very simple method. If the observations like x1, x2, x3, x4, dash, 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 xk occur number of times like f1, f2, f3, f4, f5, dash, 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 occur with frequencies, then the arithmetic mean may be different. So in first example, you can say there are 10 samples, 10 different readings are there. So summation of that divided by 10, you will get the mean. But in the second case, the readings are occur different times. For first case, whatever x1, x2, so there are again 5 cases. And 5 times the reading will appear for x1, x2, x3. So in this case, you can go for the calculation of mean by using this formula. So here you can say the mu is given by summation fi xi divided by n, or here again you can write whatever fi is there, total number it will appear. So this is, and this formula is required that we will use many times. Okay, let us move ahead. The dispersion is measured in number of units like range, mean deviation, and standard deviation. The most popular unit of dispersion is the standard deviation denoted by S. So here, very important that we will take a numerical also. So S stands for the standard deviation. The standard deviation is defined as the root mean square deviation from the mean. So here the formula is not given, means not mentioned. So we will discuss what is variance, and again we will come to the standard deviation. So standard deviation, the dispersion is measured in many units like mean deviation, standard deviation. The most popular user is standard deviation. It is denoted by S, and it is the RMS value, root mean square from the mean. So standard deviation is nothing but root mean square from the mean. So now let us see what is variance. So I will say that variance is defined as the square of standard deviation. So okay, this formula we will use for calculation of variance. This formula we will use for calculation of variance, and After calculating variance, we will just go for square root of it because the formula itself is given s square is equal to s is nothing but the standard deviation. So if we will go for square root, you will ultimately get the final answer. So before solving numerical, once again I will repeat, the mean is given by fi xi divided by n or divided by summation of fi, and then the variance we will calculate by using this, and after that you will get the standard deviation s is equal to square root of whatever answer you will get. You will put here and you will get the value for standard deviation. So wherever the standard deviation and variance is asked, we have to go for first calculation of variance because it is a square. Summation of fi xi square minus summation fi xi bracket square divided by n, and total bracket divided by n minus 1. So by before moving to numerical, what I can understand having a look toward the formula, so I will mark here some separate thing. So whatever the numerical is given, I have to go for first summation fi xi. So if you see here, fi xi is required for mean. So I will calculate summation fi xi. I will calculate summation fi xi square. And this fi xi bracket square, I can square this. So for solving any numerical, I have to calculate summation fi xi and I have to calculate summation fi xi square. If I will calculate these two values, then easily I can calculate the value by using formulas mean mu, and easily I can calculate variance also s square, and square taking square root I will calculate yes. Okay, so by looking, have a look toward the two formulas in any numerical, whatever the f and x is given, I have to go in tabular format and I will go for summation fi xi and summation fi xi square. So whatever this term is there, last term here, it there may not be any that much problem because if you can calculate summation fi xi, then square you can easily go for. So these are the theoretical formulas, friends. So let us have a numerical, and then you will come to know how to apply whatever I am saying, how to apply these formulas to calculate the mean, the variance, and the standard deviation. Let us have a numerical. So we will discuss one numerical based on this. So here 100 test specimen made of gray cast iron FG 300 are tested on a universal testing machine UTM to determine the ultimate tensile strength SUT of the material. The results are tabulated as follows. So total 100 test specimens are given. So if you go for addition of these two frequency 2, 12, 50, 32 and 4, ultimately it will become 100. Ultimately it will become 100. The class interval is given 261 to 280. So I cannot use this class as interval. Therefore, I will take here only the class as I will take average 270. Here I will take as 290 for further calculations because I have to calculate the CFI and XI. Therefore, I cannot take 301 to 320. I want one value. Therefore, I am this just modifying. So I will take either 310. Then I will say here 330 and I will say here 350. So this I have modified for substituting in the formulas. So now class interval I can say 2 I have taken mean. So 270, 290, 310, 330 and 350 Newton per mm square. And the frequency, so 270, this I can say 270. So this is, you can see here 2 times. So you can see here this 370 2 times. Then this 12 times, 310, 50 times, 32 times and 4 times. And what we have to calculate? We have to calculate the mean, the variance and the standard deviation. So see here, just now we have discussed three formulas. Have 1 minute and just take down. the numbers at least, so that we will go for constructing a table in will we will write xi, then fi, then summation fi xi and summation this fi xi square, and easily we can solve the numerical. Okay, take 1 minute to just write down. Note down the values in the table so that you can substitute these values in the further numerical. Okay, friends, let us move ahead. We have to calculate the mean, the variance, and the standard deviation. So I have taken a table. So here we have class interval. So I will say class mark because I am not taking interval for understanding purpose. I have converted it. So let us substitute one by one values. So I will take here class mark. I will call it as in our concept. I will call it as xi. Then I second I will take as frequency, and our standard notation is fi. Then I have given you items. What I want to calculate fi xi and fi xi square, not bracket square, fi xi square. So let us have this 270, 290, 310. So I will substitute here the values, friends. So very first 270, then 290, 310, 330, 350. I request you to write so that we will proceed simultaneously. Then frequencies are given 2, 12, 50, 30 to 4. So I will mention here frequencies 2, 12, 50, 32 and 4. I will give you highlight. See here 2, 12, 50, 32, 4. So the same values I have taken, and now I am making a table. So the xi I total I it is not required for me. So I can mark here that total. So this will highlight for total. So now if you go for adding this, so 12, 2, 50, 32 and 4. So ultimately these are sample as 100. Therefore, you can call it as n or you can call it as summation fi. No change, it is 100 only. So we will use this for denominator as a mean. Now let us proceed for calculation, friends. Summation fi xi and summation fi xi square. So fi into xi. So 270 into 2. So I will substitute the value 540. 10 fast. Now we have to calculate further 10 values. So we will move fast. The second 290 into 12. FIXI calculation. So immediately fastest put the values in the chat box. 290 into 12. 3480. Okay, proceed. 310 into 50. So I will write one by one. 3480. Next value 310 into 50, 15500. So okay, very nice. 155 0, 0. 330 into 32. Okay. 10560. And then next 350 into 4. Again, no calculator required here. 1400. Go for addition of this. I will call it as summation fi xi. So I will write down here only in small summation fi xi so that I will substitute in the formula directly. Okay. Go for addition, friends. 31480. Very good. So this is your first answer. The numericals are very simple as compared to other chapters. 31480. Okay. Now fi xi square. So fi is 2. See here. Fi first case 2 and 270 square. So 2 into 270 square. Huh? Calculate and substitute the values. Fi xi square. 2 into 270 square. Very good. 1, 4, 5, 8, 0, 0. Second, 12 into 290 square. This only one table you have to fill. Other just put the formula, whatever summation, and you will get answer within 1 minute. So we have to take efforts in calculating this only, this preparing the table. The further things are very, very simple. 1009 200. Okay. 1009 200. Very good. 50 into 310 square. Okay, 4805. Very nice. 4805 000. Next, 32 into 330 square. 3484800. Okay, 3484800. 3484800. 3484800. Okay. Last value 350 square into 4. Anyone? So it is 4, 9, 1, 2, 3, 4. Okay. So now if I will go for addition of these 5, I will get summation fi xi square so that I can substitute in the formula. So calculate summation fi xi square. Go for addition of these 5. 9934800. Okay, 9934. 800. 9934800. Very nice. So now let us go the formula one by one. So I will very first write down. Very first I will calculate. Step number 1. Mean, that is nothing but mu. So I will say mean is equal to summation fi xi divided by summation fi, or you can also call it as n. Well, answer will not change. So don't write, otherwise you will feel it as a multiplication. So for your understanding, I have shown. Summation fi or summation n. Summation fi is nothing but n, 100. So I will substitute here 31480 divided by 100. Friends, very simple. I can say here mean, comma, mu is equal to, huh? So no calculator is also required, huh? 314.80. You can give unit also, whatever these are the ultimate tensile strength in Newton per mm square. So you can give the unit also as Newton per mm square, no problem. So I will highlight the answer. This is mean. Let us proceed further, friends. I have given you idea. Wherever we have to calculate the variance as well as the S value, standard deviation, then go for variance first. So I will say here, step number 2. Variance. So I can calculate for step number 2 as variance. So how I can? I am having the formula. Variance is nothing but it is equal to S square. So it is square of standard deviation. So what is the formula? Summation Fi xi square minus summation Fi xi bracket square divided by n and the total divided by n minus 1. So I will substitute value for your understanding purpose. So summation Fi xi square, our value is, let us have a table 9934800. So I can say our value is here 9, 9, 3, 4, 8, 0, 0 minus summation Fi xi. So 31480. This is the bracket square divided by n. N value is nothing but 100 and the total is divided by n minus 1. So I will say here 100 minus 1. So very simple, friends. You will get the answer for variance here. Just substitute the values and calculate the answer. Tell me the answer also. 251.47. Very good. So let us move to our step number 3. That is last step, I can say, in this particular case. So I will call here as step number 3. Standard deviation. So we are having value of S square. We are having value of S square. So I will substitute here value. We have calculated it as 251.47. So I will mention here 251.47. So now you will get standard deviation. This is the value of S square. So S is nothing but the square root of 251.47. So you will get in this case 15.85. Okay, 85, 86, whatever. Okay, so I can say here standard deviation, comma, S is equal to 15.86 and whatever you can give unit also. So this is the, see, whatever what type of data is given. So from the basic data, we have to calculate the mean, the variance, and the standard deviation. So as the class intervals are given, and we cannot apply the formulas for intervals, so I have taken the mean and then I have proceeded further. So I have taken as a class mark 270, 290, 310, 330, and 350. These are the mean of the whatever class intervals are given. Then frequency is given, the different frequencies I have taken it. 2, 12, 50, 32, 4 like this. And the summation is 100. So you can call it as summation Fy. And for this case, you can call it as N also, capital N. So I have gone for calculation of Fixi and Fixi square. Why? Because I want to put these values in further formulas. So I have calculated summation Fixi. I have calculated summation Fixi square. And then I have gone for the first step, mu. So mu is nothing but summation Fixi divided by summation Fi. We arrived at answer mean mu is equal to 314.80. Then the variance S square is the formula summation Fixi square minus summation Fixi bracket square divided by n minus 1. So purposefully we have already calculated the summation Fixi square and summation Fixi. So just substituted the values and we have arrived at the one value, variance is equal to 251.47. Then last step, standard deviation. The variance is nothing but the S square value. So just taking square root. So S is equal to, you will get square root of variance, or that square root of S square, you will get the value of S, and it is 15.86. So in this way, friends, you can calculate the mean, the variance, and the standard deviation for a given numerical. This is about the frequency distribution and what are the different terms used in it, how to calculate the mean, variance, and the standard deviation. Now, let us move further of the concept probability. So, up till now, we might have heard maybe this word many times. What is the probability of happening this? What is the probability? What is the any example you can take, any example. So there are very less chances, there are very major chances, high chances. Like this, we are discussing in our day-to-day life also. So this, we will discuss what is probability. And then further we will move for the probability distribution, how to apply it for a numerical. So let us start. The very first concept is the probability. Probability is defined as the chance or likelihood that a particular event will occur, it will happen. So what is the chance, in percentage of chance? Definitely it will happen. 100% it will happen. Or there are very less chances. No chances that it will happen. So this is nothing but the probability. Probability is the chance or likelihood that a particular event will happen, will occur. In mathematical terms, the number varies from 0 to 1. The probability number, it varies from 0 to 1. The probability is 0. When we can say the probability is 0? When the event is impossible to occur. Definitely it will not possible at all to occur. Probability is 0. The probability, when we can call it as probability of 1, when the event is certain to occur, then I will call it as probability of 1. Any example you can fit into this and we can give our analysis of this probability. If there are equal chances that event will occur or it will not occur, the probability is 0.5. So these are different cases mentioned here. When there are chances that the means very less chances, negligible chances, it is difficult, highly difficult, impossible to occur or occurrence of the event, then in such case it is mentioned that the probability is 0 for occurring that particular event. When the event is certain to occur, definitely it will occur, no problem in occurring the event. Guaranteed it will be occur, it will happen. There are chances. then the probability is 1. It is 100%. So 0 means 0% and 100 means 1 means 100%. It is sorry, it is given as the number. And when there are equal chances that this may happen, that may happen, it is 0.5. So let us take one or two simple examples so that to understand or to give a clarity, I didn't mean clearing the focus on probability. The concept of probability is part of our general knowledge. If asked that what is the probability that a tossed coin will come up with a head or with a tail, so we can say the probability is 1/2, that is 0.5%. So you can say if a coin is tossed, there are two chances. Either head will be there or tail will be there. So this is based on this head and tail. Whatever the thing is there, based on this head and tail. So there may be head, there may be tail. So generalize, we can say people will answer, we can go for the probability of coming head or coming tail, whatever. So let us assume that what will be the chances that head will be there? 50%. What are the chances that tail will be there? 50%. So 1/2. So I can say here the probability is 0.5. These examples we are discussing to understand the concept of probability and how it is calculated. Then further things will become easy and easy to understand the concept of further concepts like probability distribution and further related numericals on it. If we take a six-sided cube with numbers 1 to 6 on its faces, so this six-sided cube in many of the games we are using the six-sided cube, and we will just put it and let us see. 1 will be there, 2 will be there, 3 will be there, 4 will be there, 5 will be there, and 6 also will be there. What is the probability that number 5 will occur? I can say 1/6. Probability of 5 will occur, 1/6. Number, what is the probability that number 1 will appear? 1/6. Number 2 will appear, again that. So probability, whatever you take the number, the probability is 1/6, because any number can appear in such case. Then we can simply say the probability is 1/6. So these are the two examples. First we have discussed by taking example of a coin, and second now the six-sided cube. So let us express in terms of some mathematics. These examples only in terms of some mathematical formulas. So in more precise terms, the probability is defined as a number p which varies from 0 to 1 and which indicates the chance that a particular event E will occur, given that it can happen F ways. So F is different ways. How many ways it can happen? So F ways out of n equally likely ways. So what is this F and n? So just same example we can take. So six-sided cube, one may be there, one may be appear, two may appear, three may appear, four may appear, five may appear, and six also may appear. So this is just F. So 1, 2, 3, 4, and 5, 6. So equal likelihood. So anything can happen. Therefore, this probability P is given by. So P is event E. So what is the probability that E will be for about event E? So it is F by N. F ways divided by N. So let us take an example. Suppose that we toss a coin 20 times. So N is 20 here. A coin is tossed 20 times. N is 20. And we get 12 times head. So here F with your 12 times you have head. So probability is F divided by N. 12 divided by 20. So 0.6 or 60%. So this is probability. Again, I will take same example. Suppose we have tossed a coin. Again, I will take N. 20 times a coin is tossed. So now I am getting tail I am getting tail 14 times, or let us say 14. So F is equal to 14. So what is the probability is F by N? 14 divided by 20, it is 0.7, or I can say 70% chances are there. So this we are taking just the examples that what is the probability, and again only one time it is toss, head and tail different. Now the coin is tossed 20 times. So the coin is tossed 20 times and we have measured it, and then the examples are taken that this is happening. Okay. So now making generalized statement. Although the answer is 0.6 or 0.7, if the coin toss again and again for large number of times, large means I say we have tossed 10,000 number of times, the probability it will come up with heads is 0.5 only. So here generalize again, I hope it is mentioned generalize. So 20 times you can measure here 20 times. Okay. So we have arrived at 0.6. But if the coin is tossed again and again large number of times, I say 10,000 times, 1 lakh times, 50,000 times, 2 lakh times, 5 lakh times, then again the probability of having head is 50% and the probability of having 10 is 50%, tail is 50%. So this is very important thing. Now if the event does not occur, if the event does not occur, it is called as not E. So event occur, we have seen. If the event occur, then we have denoted as this particular E. Event E has occurred. So now event E has not occurred, not E, or it is also written as so something like this. So E, and on E a sign is mentioned. So something like this. Then the probability that the event will not occur, the probability that the event will not occur is like this, PE. So event occur PE without sign, and event not occur P, and on the top or head of the there is sign. So I can say PE. The probability that event will not occur P into E is 1 minus PE. So what is this 1? 1 minus, this is the answer for event will occur. We have already seen here P is event occur and small p. So here small p stands for event occur, small p stands for event will not occur, and ultimately where q is the probability of non-occurrence, here p is the probability of occurrence, p is the probability of occurrence of the event. We can say q is the probability of non-occurrence of the event. And what is the probability of non-occurrence? It is 1 minus PE. So 1 minus probability of occurrence. And ultimately we have to keep in mind that probability of occurrence and probability of not occurrence should be equal to 100%, or I can say 1. Definitely. Occurrence and not occurrence. So it is 1 minus. So 50% times occur, 50 times not occur. So this 50 and 50 will become 100. 60 times occur, 40 times not occur, 70 times occur, 30 times not occur. So if you can analyze this, so ultimately you will get the answer as P plus Q. So what this stands here, P for probability, occurrence plus not occurrence. So I can say here probability that event will occur plus probability that event will not occur. So this is nothing but, and this always should be equal to 1. So once again have a highlight towards this point. So E is the event will occur and small p is the probability of occurrence. So probability that event will occur is given by F divided by N. So F is the number of times f weight out of n. So how many times? So for example, n is 20 and f is 12 times the coin is having head. So f is 12 and n is 20. So we have taken one example here. So now if the event is repeated, or we can say the coin is tossed for 10,000 times, 1 lakh times, then the probability of occurring head or occurring tail, we can say it generalized concept 50% only. So if the event does not occur, it called as not E, denoted as I have shown on the head of E1 symbol is made. And the probability that event will not occur is written by Q. So written by small p, event will occur, written by small q, event will not occur. And it is equal to, event will not occur, the probability is equal to 1 minus p minus E, event will occur. Because ultimately we know that the probability of event will occur and event will not occur is equal to 1. Event will occur and event will not occur is equal to 1. So this is about the concept of probability. We can take a large number of examples here to understand the concept in much deeper and much broader way. So probability is the chance or likelihood that a particular event will occur. And we have discussed in detail when the value is 1, when the value is 0, what are the chances that it is 0.5, and we have taken two different numericals and we will also come to know. Okay, so this is